Yeah, you're welcome to this next lesson in mathematics, that is application of area of circles in various shapes. So let's have a look at that. That's my shape. It's in form of that's a rectangle generally. Now I want to put circular objects in that rectangle. So how do I need to put? Of course, there I will put that first circle, put the second one, put the third one, put the fourth one. Remember, my circular object is having a diameter of 4 centimeters. Now, if this is 4, this is 4, this is 4, this is 4, you can be able to tell now the length of our rectangle. Of course, that becomes 4 times 4, which is 16, or you can say 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters to take you to 16. What about along the width? How many circular objects are there? We have 3 of them. 1, 2, 3. That means I have 4 plus 4 plus 4, still to give us 12. You know that. Now we know the length of our figure, which is 16 centimeters, and the width is 12 centimeters. Good. Let's continue filling in. That goes there, that goes there, that goes there. Yep, yep. Coming up with a very nice pattern. And if that was a cloth, you'd feel like buying and paying me a lot of money, which is good. Now, back to our mathematics still. How many circular objects do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. Good. Now, remember we added 4 to 4 to 4 to 4 to come up with 16. What about the width? It's 4 plus 4 is giving me 8 plus 4 to give me 12. Now, what is the connection between this 16? Look at the relationship which is among these items. 4 centimeters here, 16, and the 4 circles along the length. If you look at that very well, you'll discover that if you get 16 centimeters, then you divide by 4 centimeters, you are going to come up with 4 circles. Now suppose I don't have 16 and I have those circles, and the other, I have these 4 circles and this one here. Can I easily get 16? Yes. You just get this 4 and multiply by the 4 circles. That will give you the length of your rectangle, which is 16 centimeters. Let's look at the width. What is the relationship among these? This 12, 3 circles, and this diameter of 4 centimeters. If you look at the multiplication table very well, you'll discover that if I multiply 3 by 4, I'll come up with 12. Then if I divide 12 by 4, I'll come up with 3. So you'll discover that if you divide the width of this rectangle by the diameter, you'll be able to get to know the number of circular objects along the width, which is good. Those are the major areas you need to know. How do you get the number of objects along the length? How do you get the number of objects along the width? The moment you get to know that, the rest will just be a walkover, and you'll be able to design as many patterns as you want using any shape you feel like. So we can continue to the next. And since we got 4, we counted this and came up with 12 circular objects. We can also use, here we have 4, that's there, and the width we have 3. I think we can also have 4 multiplied by 3 to come up with 12. So if I don't want to count, I just need to multiply the number of circular objects along the length by the number of circular objects along the width to come up with the number of objects or patterns that can be got from that big figure. Now let's look at our first example. We now apply it in this. A piece of rectangular paper 35 centimeters by 21 centimeters is designed with circular paintings, each of diameter 7 centimeters. Now, how many circles were in the design? I don't have the piece of cloth here, but how many circles were in the design? Let's look. That's my shape. I have this big rectangle, and I have this first one, this first circle along the length. Then there's one which is okay, touches both the length and the width. But if you look at these, are mainly representing the diameter which can fit the length, the total circle that can fit the length. So to get that, we now need to apply what we had at the beginning, that is dividing 35 centimeters by 7 centimeters. So let's look at the circular painting along the length. Along the length, we shall have 35 centimeters divided by 7. What do I come up with? I'll come up with 5. So there I'm going to get 5 circular objects along the length. What about along the width? You can see I have 21 centimeters, which is the width of my figure, width of my rectangle, and 7 is the diameter of my circular painting. But this same diameter is vertical, which is covering the width. So I will still need to divide 21 centimeters by 7 centimeters, giving me 3. So to get the total number of circular objects, just multiply 3 by 5, 5 by 3 to come up with 15 circular objects. That is the number of circular circles that can be, or that were found in the design or that piece of paper. Let's look at the next question. But before we go to the next question, I want to take you back. To this. Remember, even after filling in, there's always space left. I think our next question is going to handle that part of the space left. So let's look at that part of the space left. What is the area of the paper without circles? I took you back and you saw that there were some spaces which did not have paper. So how do we get that? First, you need to find the area of the rectangle. And our length was 35. We are multiplying by 21, which is that. And 35 times 1 is going to give us 35. Then I multiply 5. 2 times 5 is going to give me 10. So I have to write 0 and regroup 1. Then 2 times 3 is 6, plus the 1 that we regroup to give us 7. Finally, add that, you get 735 square centimeters. That is the area of the whole rectangle having circles and the ones which are not, and the parts which are not covered by the circles. Now, let's look at area of 15 circles. Remember, area is equal to pi r squared. But because we have 15 identical circles, we shall multiply by 15. So we have 20 out of 7 times 7 times 7 out of 2 centimeters. Why do I have that? The first 7 was the diameter. But here we are dealing with radius, and radius is a half of the diameter given. That's why I have 7 out of 2, so that I come up with the radius. Times again 7 out of 2, then times 15, because we have 15 circles. Let's continue. Divide that. 7 divided by 7 is 1. 7 divided by 7 is 1. Then 2 divided by 2 is 1. I'll need to divide 22 by 2 to give me 11. Now it's just a matter of having these numbers multiplied. 11 times 1 times 7 times 15, which is giving me 1,155 out of 2 square centimeters. Take your time and multiply. Show your side work and you carry out that multiplication. Now you need to divide. Now when I divide this by 2, I'll get 1. Now 1 divided by 1 is 0. I'll remain with 1. So when I bring here, I'll make 11, since we're dealing with base 10. Now 11 divided by 2 is giving me 5. 5 of 10, remainder 1. The remainder is brought here, make 15. 15 divided by 7 by 2 will give me 7 of 14. Still the remainder will be 1. Bring that 1 here to make still 15. 15 divided by 7, sorry, by 2 will give me 7, and the remainder is 1. So at the end, what do I come up with? 577, remainder 1. So my area is going to be, the area of 15 circles will be 577.5 square centimeters. Or if I don't want to use a decimal point and I want to use fraction throughout, my area is going to be 577.5 square centimeters. Now, how do I get the area of the space not covered by circles? Carry on subtraction. Subtract these two. Get 735.0 square centimeters, take away 577.5 square centimeters. Now, 0 take away 5, 0 is less, I need to regroup. I'll have 10 there, I have 4. 10 take away 5 is giving me 5. Then 4 is still less, I need to regroup. That becomes 14, I remain with 2. So 14 take away 7 is giving me 7. What am I left with? That 2. 2 is less than 7. Still, I'm going to regroup. And when I regroup, I'll now have 12, and 6 will remain. So 12. 12 take away 7 is going to make me have 5. And finally, I have that 1. So my area of the space without circle is 157.5 square centimeters, or someone can say it as 157.5 square centimeters. Now let's look at example 2. This time we're going to the welding group. So these people use metallic sheets all the time, in most cases. A welder cut circular metal sheets of radius 7 centimeters, again the same radius, from a square sheet of side 70 centimeters. It is still a square metallic sheet. I repeat, it is still a square metallic sheet. Oh, there's a problem here. It's a welder cut a circular metal sheet. Okay, fine, it's fine. But suppose a metallic, let me have it corrected. Let me have that corrected. A welder cut circular metallic sheet. How many circular sheets? Yeah. I think we are now good to go. We're back. I can say a welder cut circular metallic sheets of radius 7 centimeters from a square sheet or a square metallic sheet of side 7 centimeters. How many circular sheets did she make? Hey, this was a female welder. Yeah, that's great. So let me try to sketch. That's my square metallic sheet, and the circular part is there. Since the radius was 7, we normally deal with the diameter, because when you cut a circular sheet, it covers the diameter, not the radius. So what we need to do at that point is to get the diameter, which is the same as radius plus radius, and we shall have 7 plus 7 to give us 14. That's why I have 14 centimeters as my diameter. And with that case, I need to find a number of circular sheets that can be cut along the length. And since it is 70 now divided by 14, let me just divide direct, that is 1. And how many 14s are in 70? We have 5 of them. So that is 5. That means along the length, we have 5 sheets that can be cut. What about along the width? Still the same thing. we have 5. Now, how many sheets do we have? Just have it multiplied, that is 5 times 5 to give us 25 circular metallic sheets from that square sheet. We can continue to the next. Calculate the area of the remaining metallic sheet. Calculate the area of the remaining metallic sheet. Still, from that, you need to get the area of the square sheet. You need to get the area of the square sheet first. After getting the area of the square sheet, which is giving me 70 times 70, and that takes us to 4,900 square centimeters. Then we should also get the area of 25 circular sheets, which is pi r squared times 25. Pi r squared is for one circle, but because we have 25 of them, then we are supposed to multiply by 25. So we have 22 out of 7 times 7 centimeters times 7 centimeters times 25. Why do I have that? 7 is our radius, and we shall not divide again by 2. So 7 divided by 7 is giving me 1. 7 divided by 7, that is giving me 1. So I have 22 times 7 times 22 times 7 square centimeters times 25. That takes us, let's have the side work. We have 22 times 7, which is 154. So it is 154 times 25. So we have 5 times 4, that gives us 20. So what do we do then? You just need to write 0 and regroup 2. Now we have 5 times 5. That is 25 plus 2 to give us 27. So we're going to write 7 and we regroup 2. Now the 2 that we have regrouped, is not appearing here, but I'm supposed to have 5 times 1. 5 times 1 is giving me 5 plus the 2, which are regrouped to give us 7. So the next one, we need to multiply this 2 by 4 to give us 8. Then 2 times 5 is 10, but now I will have to write 0 and regroup 1. So 2 times 1 is 2, plus 1 to give us 3. Finally, we need to add 7 plus, 0 is coming there, then 7 plus 8 is 15, write 5, regroup 1, and finally add that, and you come up with 3,850 for the area of the 25 metallic sheets. Now we want to find the area of the remaining sheet. Area of the remaining sheet will be 4,900 square centimeters, take away 3,850 square centimeters. When we carry out the subtraction, that becomes 5. Sorry, the 5 is coming from 10, take away 5 to give us 5. We regroup because 0 was less. So here I have 8, take away 8 to give us 0. And finally, that becomes 1. Now, the area of the remaining space is 1,050 square centimeters. Some people may be wondering that why is it that the area which is remaining is bigger than even the area of one? Because the area of only one sheet is 154 square centimeters. But now the area is 1,550 square centimeters. That one happens because a square, a circle does not have really, it's able to leave bigger space when packed, like the way you saw in the first example. The patterns formed are ever going to form other patterns if it is to be cut off. So that area remains because of the shape of a square. If we had objects like, if we are putting rectangular patterns or square patterns, the area left would be smaller than almost the area of the bigger figure. And that's why when you go to parking, I know time will come that the person who is under parking will explain to you why most items are packed in rectangular boxes or boxes in form of cuboids, but not boxes in form of cylinders. Very few items are packed in boxes because of in form of cylinder, because of the space, the amount of space wasted or the amount of space left by the circular parts. Otherwise, I wish you the best. Download the exercise and your answer. See you when you see me, and remember to always stay safe during these tough times of coronavirus. Bye.